I do not know that yet. Probably in the cafeteria or one of the gyms. That's traditionally where it usually is held. Okay. And it is. We do know. Have we gone over when it is? That Tuesday, first Tuesday of midterm week. So we have class on Monday, and then the midterms on the 23rd. So 2 weeks from this Tuesday. Okay. So midterm is on. It's your. I don't know how many midterms you guys are taking, and I don't care. Sorry, but I don't care. But I can guarantee we're the first midterm you take. Okay. Math will be because math is all on that Tuesday, and it'll be in the afternoon at 1 o'clock. And for you freshmen here, never experienced midterm week, you don't come in unless you have a midterm. So you guys don't come in until 1 o'clock that day, or earlier if you want to come in and review with me. So that's the deal. All right, because our midterm is 1 to 3, 1 to 3 o'clock. It's only 2 hours, and you only have 2 hours to take it. I don't know why I keep talking about the midterm when we're not.
You have to stay like all day on midterm week.
What do you mean?
Like you have to come in every day.
No, you only have to come in when you have a midterm. Or me? Yeah, I got to be here every day. Yeah, I don't get free time out, enjoying the weather. No. Yes, I will be here every day. It's only 4 days. So you guys have your midterm on Tuesday. I'll probably correct it on Wednesday, pop it up on Aspen for you guys. And then I have a senior group that's taking a Regents exam on that Thursday. So I'll be plenty busy. Ian, I know you were worried about me. I appreciate it. All right. But yes, I will be here every day. It's going to take me a while to correct all those midterms too. So, all right. So here's the deal today. What happens after you prove triangles similar? Well, you guys tell me. If you know two triangles are similar, there's two things you know. Corresponding angles are, if two triangles are similar, the corresponding angles are congruent, but the sides are in proportion. That's what you're going to prove to me today. Why are the sides in proportion? And they're not in proportion until the triangles are similar. This is kind of sounding familiar, isn't it? Didn't we do this for congruent triangles? But we did what instead? CPCTC. Yeah, now you're going to meet its cousin today. All right, once triangles are similar, why are the sides are in proportion? So that's the first thing we got to do today. If you take a look at this first proof, I'm asking you to prove the sides are in proportion. Look at my diagram. I don't know if you guys picked colored pencils up as you came in. If not, no big deal. Look at my diagram, though. I have an issue right away. I see 1, 2, 3 different triangles in this diagram. How the heck am I going to know which two to prove similar then? Look at the sides in the proof statement. Ready? The first side that's listed is CE. Look at your diagram. Can you find a triangle where CE is a full side? And it's a full side of only one and only one triangle. Can anybody see that? Triangle CED. So I know it's going to involve triangle CED because CE is a full side and one triangle only in that diagram, and that's CED. All right, let's keep going. The next side they list is DE. Well, I already took care of that, didn't I? DE is a full side in the triangle I just highlighted. All right, so where's the other triangle? Let's keep moving on in the proportion. BE. Oh, let's see. BE, I can only find one triangle where BE is a full side. So now we have our two triangles to prove similar. So use your proportion to find the triangles. All right, what's our main method we're going to use to prove them similar? AA, angle, angle. All right, so you guys are on the hook. Here we go. Find me two pairs of angles. And you were given it's a parallelogram. Don't forget that. All right, who's going to be first up today? Let's see. First up, give me a pair of angles. I think I already have it. Yep. Shoom, Aiden, hello.
You could say DEC is congruent to BEF.
Darn right. Yep. Might as well just go with the verts, right, when we see them. Angle DEC is congruent to angle BEF. Vertical angles congruent. All right. Thank you, Aiden. One pair of angles down. I need another pair now. And remember, givens are provided for a reason to use them. So there had to have been a reason why they said it was a parallelogram. All right, got another pair of angles for me. See another pair anywhere there other than the verts. other than the vert. Zeef?
Angle C and angle CBF. That's parallel.
These two right here?
Yeah.
All right. What type of angles are they? All right. Hey, everyone. They're not going to be congruent in step 3, though. Right? I'm not going to write those angles are congruent. Those angles aren't congruent unless I have what type of lines? Parallel lines, right? Alternate interior angles aren't congruent unless I have parallel lines. So the first thing I need to say is DC is parallel to AB. And remember what I showed you last unit? If you are unsure what line should be parallel, just put them both, because it's true, right? If you're unsure what line should be parallel to make those angles congruent, put both. And this is because from last unit, this is a parallelogram, and that implies opposite sides parallel. Now you can tell me the alternate interiors are equal. So angle C congruent to angle EBF. Yep. And we wrote this yesterday. Parallel lines imply alternate interior angles congruent. All right, now you have angle. Now we have angle. All right, unlike yesterday, you're going to have to come up with your own similarity statement. So please make sure the angles and sides match up when you write it. Name the first triangle however you want. Triangle DCE. I messed this up last period. DCE FBE by angle. Check your who just put the congruent symbol again? Anybody? Are we getting better at this? Okay, good. All right, now the triangles are similar. One extra step today, corresponding sides are proportional. So now we could say CE over DE is in the same ratio as BE over FE. And here's our reason. Yes, sounds the same as CPCTC, but corresponding sides, similar triangles are proportional. CSSTP. And my rule still applies as it did with CPCTC. If you want to use that abbreviation, got to do it in the right order, all right, with the right letters. All right, anything there using CSSTP? I'm not going to do a whole bunch here with you today, as you can see in your notes. There's no reason to. Once you pick it up, you got it. Oh, look at this one. How about that proof statement? The heck is that? Those colons? What? What's the deal there? What am I asking there? Same thing I asked in the last proof. I don't know if you guys remember the very first thing I showed you in this unit was, or maybe I didn't, 3/4. You guys call that a fraction. That's what you've been calling it all your life, but it's actually a ratio too of 3 to 4. So these are the same things. So if you feel uncomfortable, you're getting nervous, you're sweating, I don't know, whatever, you can always write it like this. Same thing. All right, the colons mean it's in a ratio. All right, I know you guys are marking your diagram, which is great, but I'd like to find what triangles to prove similar, because there are actually 4 here, I see. 1, 2, actually 5, right? 1, 2, 3, the big one, 4, and then this small one here, 5. So which ones am I going to prove similar? Ready? FC, everybody, FC. Is FC a full side in one and only one triangle? I believe it is. Triangle FCA. Oh. All right, DB. DB. Is that a full side in one and only one triangle? Oh, yeah. So we are done right away. It's got to be those two. All right, take your time, please. I'll give you a second to get your thoughts together, because I did provide a ton of givens here. There's a lot of vocab. Isosceles triangle, altitude, and I gave you perpendicular line. So get your thoughts together before I call on somebody to give me the first pair of angles that you see. All right, you ready? How about a pair of angles for me? Anywhere, anywhere. Gabby, hello?
Angle ABF and ACF.
Yep, good job. These two right here, Gabby's giving us. I love it. So let me put that down, and I'll ask somebody else why, because obviously Gabby knows. So I'm going to say angle B, because that's the only angle there. But I won't say angle C. I will name it with 3 letters, ACF. So why are those two congruent then? What's Gabby's reason there? One's it, Matt. Here we go.
Isosceles triangles. Opposite angles are congruent.
Yeah, that's fine. You can write that. I do the old in a triangle, whether it's isosceles or not, right? In a triangle, congruent angles are across from congruent sides. Good job. All right, where's my other pair now? Where's the other pair here? Talk to me. Z, back to you.
The altitude and the perpendiculars are very close.
So I have 2 right angles in the diagram. And this is very, very, no pun intended, similar to yesterday. Those have to go in 2 different steps. Why? It's got 2 different reasons. All right, they're both not right angles for the same reason. So first, let's do angle BDP. Angle BDP is a right angle. BDP. Why do we put a right angle there? What's the reason for that one being a right angle? Take a look. BDP. This one right here. Why is that bad boy a right angle? Haley, hello?
Perpendicular lines.
There you go. And then now, why is AFC a right angle? Different reason. AFC. How do we know to put a right angle symbol there? Take your time. Charlie?
Because definition of altitude.
Yep. Definition of an altitude. Altitudes form right angles from a vertice. But don't forget, we don't have angle yet. We have angle nothing. I got to say the right angles are congruent to get angle. Angle. No issues. 7 steps. Now say the triangles are similar. Triangle AFC. BDP. Or BDPDB. And I don't care what you write for the last statement. You can write it as colons, as a ratio, or as a fraction. I don't care. Write it as a ratio or a fraction, whatever. With the colons or the fraction bar. I'm sure most of you will write it like this because you want to impress people. Okay, any questions with the proofs before we do one algebra one together? Oh, I'm going to get you on this one too. I'm going to challenge you here. You think you're good. You think you're good. Okay. Wait till we try out this one now. All right, I'm going to knock even the studs down in this class. All right, given AB parallel to CD, we have gone over. They do need to give us that because that makes both triangles similar, so we can write a proportion now. All right, without it, this problem cannot do. All right, here we go. Give me one side from one of the 2 triangles, please. Full sides. Give me one full side from either of the 2 triangles. I don't care what. Just start us off somewhere. Let's go, Aiden.
4.
4. Got it. Very direct. Thank you. 4. 4 matches up with what in the big triangle? 4 matches up with what side in the big triangle? Zoe. X plus 3. There we go. Done. All right, give me another side in the small triangle. Because Aiden started out with 4. That came from the small triangle. So now I want another side from the small triangle to put across from it. And what's the other side that we know, Ian? X minus 1. And now you guys left the hard part here to finish. X minus 1 corresponds with what side or side length in the big triangle? Now, be careful. X minus 1 corresponds with what side or side length in the big triangle? Where are you going here? All right, show off. Time to show off, Will. X plus 1. Good. If some of you are wondering where young Will got that, took X minus 1 and added it to 2. And I haven't seen this yet when I walk around for homework. Don't leave it like that and put it in your... What are you going to do with that when you put it in your proportion? I don't know either. Combine your darn like terms. X plus 1. Good, Will. All right, we ready? Cross multiply time. This is where I'm going to knock some of you guys down. I got 4 times X plus 1. Little double distribute. Remember, you say that FOIL word in my class. Headlocks and roundhouses. Roundhouse kicks. All right, serving them up. Double distribute. I get x squared. When I combine my like terms, I get 2x in the middle and negative 3 at the end. Again, I can't stress this. If you're having difficulty, just come in one 15-minute session with me. All right, we'll go through a ton of double distribute problems. Do we want to see where we got the 2x comes from? Negative 1x plus 3x. That's where that comes from. All right, you guys know what's next. Don't even start talking about factoring or quadratic formula yet. Why? Still need it. Equal to 0. Yep. And now look, my x squared's positive. Keep it that way. Move over the 4x and the 4 for me. So x squared, what's that going to be when I move over 4x? Negative 2x. And then when I move over the 4, negative 7. You guys are in honors, so here we go. If you can factor, factor it. I don't want to resort right to quadratic formula immediately. What are you thinking? 2 numbers that multiply to negative 7 and add to negative 2? Anything? They don't exist, do they? Because, guys, the only options you have are what? 7 and 1. There's no way you're getting a 2 from that. So this is unfactorable. You can't. Are we good? Unfactorable? Hey, also, whoa! I knew right from the beginning of the problem that this was going to be unfactorable. I knew right away I wasn't going to have a shot at factoring it. See the directions? Find x in simplest radical form. What's the only thing that's got a radical that we use? Quadratic formula, right? So right from the directions. If you didn't see it, fine. But if you do notice it, keep in your mind, whoa, when time comes, there's no shot at factoring. I got to go right to quadratic formula because it says my answer has to be in radical form. All right, here we go. Quadratic formula time. I'm still not done with you either. What's my A value? Actually, you know what? A, B, C. I'll call on somebody for that one. A, B, and C. What do you got for me before I plug it in? 7. Amy, what do you got for A? 1. B. Watch your mouth. Good. C. Negative 7. Good redemption. All right, here we go. X equals negative B, so that'll be a positive 2, right? Negative 2, plus or minus. I'm hoping you guys are listening to what I'm throwing down here and putting these things in parentheses as you plug them in. B, negative 2 squared, minus 4 A, C, all in parentheses, all over 2 times that A value. And again, that's all I require to see when you use quadratic formula, because I know you guys will plug it into your calculator. Do that all the time. I don't put it in a fraction first. And I don't know how to.
You just click it. Like click out.
All right, relax. Go ahead. Yeah, good, good. Yep.
Then hit the,
Oh, thank you, everybody. Well, the 2 still
yeah,
added
so
up.
just like you delete the 2.
Or you could hit parentheses.
Or how about I just do this and do it over? There we go. One and 2 radical 2. Whoa, 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 whoa. I wouldn't be boxing that in just yet. Wouldn't be boxing that in yet. So how long are we going to stare awkwardly at each other until somebody tells me why I don't want to box that in? You want to challenge period 3 new. Somebody in period 3 new. How, I don't know, but why is that not my answer? Save your classmates, Josh.
Wait, do you have to like substitute it back in, like one of the sides?
What do you mean? Continue on with your discussion there. I think you might be getting it. Maybe not.
And if it's positive, keep it, and if it's negative.
When you guys, right? Hey, when you guys factored, right? I don't know, maybe you got x equals 6 and x equals -2. You plugged them back in, and if one gave you a negative side, you rejected it, right? Well, just because we're using quadratic formula, we got to check that too. So real quickly, take a look at my numworks here. I get 3.8. Look at your diagram. If I got 3.8, is that an okay side? Is that okay value of x? It is, right? But there's another answer other than 1 plus 2 radical 2. And what is it? 1 minus 2 radical 2. And look what I get there. And you tell me if that's an okay value of x in that diagram. -1.8. Is that an okay value? Not for AF, it's not. It's going to give me a negative side length. So even when you use quadratic formula, if there is a diagram with the problem, you need to check if it's going to give you a negative side length. All right, so my only answer here, 1 plus 2 radical 2. So please watch out for that. Watch out for that. Even with quadratic formula, you need to check your answer if it's got a diagram.